All right, guys, this is the review for the test. Let's start. Okay, the first one is, let me zoom in a little bit so we can see this clearly. Let's go to 150. All right, so the first one asks for the domain. So remember domain, first this is a discrete um, function, a discrete graph, all right? So remember, if you see points on the graph, it's discrete. So let's go ahead and answer this one right now. So this is a discrete. And is it a function? No, because I have 2 points directly under each other. So when I draw a line, it's going to go to both points. So that's not a function. So the function is no. All right. Okay, let's look at domain now. So remember, domain, we're dealing with x values. I want to find the x coordinate for each point. And I'm going to start at the leftmost point. And so the first point on the left side is going to be this one. I go up to the x-axis, that is -3. The next point is here on the y-axis. So when I go up, that is 0. The next one is here. I go up, that is 1. And here, this point 2 is also 1, the x-coordinate, but I'm just going to write it one time. And the next point over is 4. So my domain is -3, comma 0, comma 1, 4. All right. Okay, let's find the range now. The range, I'm going to go from the lowest point of the graph, the lowest point, and I'm going to go towards the y-axis. Okay. So let me erase this and see now. My lowest point is right here, but guess where it's at? It's already on the y-axis, so I'm not going to move it. So that's going to be 4 right there. The next one up is right here, and I go to the y-axis. That is, I'm sorry, that's a -4. I go over that's -2. But also, this one is -2 too. But I'm just going to write the point one time. The next one up is this one. That is 3. And the next one up is 3. And so the next one up is, I'm sorry, this one is 2. Uh, oops, let me go back. I am, my eyesight is failing me. This one is a 2. So this one is 2. And the last one up, that is 3. Okay, sorry about that. So that's the domain right there. Okay, so that's the domain and range. And let me check my answer key. Did I make any mistake? Yeah, I had to correct on my answer key. I just messed up. All right, let's look at the other graph and let me make this. Let me scroll over. Uh, View, zoom, 200. I'm not sure why. Okay, I can see. All right, so is this, I want to start from the bottom. Is this a function? Yes, because when I draw a line through the graph, all right, when I do the vertical line test, the line only crosses the graph one time. So yes, this is a function. Is this continuous? Yes, it is continuous because it's a line. And so I'm going to put continuous. Okay, it's what about the range? Well, let's see. Now the range, remember for the range, we're going to start at the lowest point of the graph, right? Look at the line. Where's the lowest point? The lowest point is right here. But guess what? That's an arrow. So we know that's going to be -infinity. And we use a less than symbol with that. Where's the highest point on the line? The highest point on the line is this point right here. And if I come down, if I go over to the y axis, right, that is going to be 1. So 1 is right there, but because it's a closed circle, I'm going to use the less than symbol. And therefore, I put my y in the middle. So the range is from -infinity to 1. Now, we can also write this in a different format, all right? We can write this as y is less than, all the y values less than equal to 1. Why is that? But look at the graph, right? All the y values for this graph right here, all the y values, right? We start off at 1, and then all the y values are going down. See that? All the y values. The graph doesn't exist above 1. It doesn't exist up here. So all my y values in this graph are going down. -5, -6. Sorry, use the red. -6, all the way to infinity. All right? So the y values are all less than or equal to 1. So that's another way I could write my answer. And we'll talk about this in class tomorrow or on Monday. All right, domain. Let's talk about domain now. Remember, domain are x values, and I'm going to start at the left side of the graph. All right. So let me go ahead and erase this for a second. And so my domain now on the left side, the graph starts at -4. And if you notice, this is a closed circle, so I'm going to use less than or equal to. Now, on the right side of the graph, right, what we have here, the arrow. So I know this is going to be positive infinity. And I use a less than symbol with that. And we know we'll put my X there because I'm dealing with domain. Now, another way I could write this is, now look at X values. All the X values are going this way, right? They're going towards the right. So they're all greater than -4. They start at -4 and start increasing. -3, -2, -2, -1, 0, 1, all the way to positive infinity. So I can write another way I can write a domain is all the X values, right, that are greater than or equal to -4, right? Another way I could do that. All right, so that's 1 and 2. Let me use this. Go back to Zoom. Let's go back to 100 and see what I have here. Uh, okay. Given the equation x plus by equals c, a equals 4, b equals 2, and c equals 16, we're asked to solve for y. Now, you guys struggle on this. So remember, the first thing you're going to do is replace the letters, right? So we know A is 2, A is 4. So the first equation, we know A is 4. So that's going to give me 4x. B is 2, so that's going to give me 2y. And C equals 16. Now, we're solving for y. Okay, so this is my target right here. But I can't get to 2y first until I cancel this 4x. All right. This 4x now is a positive 4x, so therefore I'm going to subtract 4x there. On the right, I must do the same thing. Now, notice what I do. I put my -4x off to the side. I don't want to confuse that. I can subtract these two, 16 and -4x. You can't subtract them or add them. Okay. Now I'm going to draw my line. Okay. Now this goes away because I'm going to cancel it. And on the left side now, I'm gonna bring down the let's put a red. I'm gonna bring down the 2y. On the right side, I can't add or do anything. I can't combine these terms, right? I can't. So I'm gonna bring down the 16. I'm also gonna bring down the 4x. So now I'm gonna have 2y on the left side, 16 and minus 4x. Now my next step now is I have 2 times y. So what I'm going to do now is I'm just going to divide by 2 here. Now I want y by itself. And this is 2 times y. To cancel it, I'm going to divide by 2. Divide by 2 here, divide by 2. That goes away. So I'm left with y is equal to 16 divided by 2 is 8 minus 2x. Now remember that the preference is to write the 4x first. So normally I would write this as y is equal to -2x plus 8. All right. This is the perfect way to write it. If you give me this answer, I will take it. I'll take it. But this is the perfect way of writing the answer. All right. So that was number 3. Let's go ahead and look at number 4. Let me go ahead and erase this now and do number 4. Okay. All right. Extend the page for a bit. Number 4. A is 5, so therefore I'm going to have 5x. B is 2, so I'm going to have 2y, and C is 20. Remember, solve for y, but I have a 2 times y, so I can't touch that yet. I have a 5x here, so to eliminate the 5x, I'm going to minus a 5x first, and also do the same thing on the right side. But remember, I put my 5x off to the side. Do not put it under the 20. Do not put it there, because you tend to combine those two terms, and you can't. So move it off to the side, draw my line. That goes away. So now all I'm left with now is just a 2y on the left side. So I'm going to bring this down. On the right side, I can't combine these terms, so I'm just going to bring down the 20 and bring down the negative 5x. So that's going to give me now 2y on the left side now. I have the 20 and negative 5x. I'm going to write the 5x first, negative 5x first. So I'm going to put negative 5x there. That goes first, plus the 20. Now I can touch the y now. I'm going to divide by 2, divide by 2, divide by 2. That goes away, so I'm left with y is equal to now negative 5 over 2x plus 10. All right? All right, next one is number 5. Here, very similar problem. We're going to solve for y and then graph it. All right? Not the best graph, but we'll work with this one. So let's do it over to the side here. All right? So a is 1. That's going to give me 1x or just x. Plus my b is 2. But my b is negative 2, so that's going to be negative 2y. And my c is negative 8. Okay? Again, this is what I want, but I can't touch it yet because I have a 1x or an x to the left side of it. So therefore, I'm going to minus a 1x here, or just the x. And on the, okay, if I can squeeze this off to the side here, negative, I'm putting negative x, right? So it's still 1x, guys. I'll just put a negative x right there. Don't get confused, right? I just have no space. And so I'm going to draw my line. That goes away. So I'm left with now on the left side my negative 2y. So I'm going to bring that down. I'm going to bring down the negative 8 and the negative x because I can't combine those two terms. So I'm going to have now a negative 2y. Now I'm going to write the negative x first, all right? Equals to negative x minus 8, or negative 1x. Divide by negative 2 now. Negative 2, divide by negative 2, divide by negative 2, divide by negative 2. That goes away, so I'm left with just y is equal to, now remember there's a 1 here, all right? We just don't write it. There's a 1 right there. So that would give me negative 1 divided by negative 2. That would just give me a positive 1 over 2, 1 over 2x. Negative divided by negative to give me a positive 4. All right? If you need to pause and go back and look what I did, go and do that. Now, we know from the slope intercept form that 4 is my y-intercept. So that's 0, 4. That's my y-intercept, all right? And my slope is going to be 1/2. We have the equation here, all right? So that goes right here. Okay, there was no x-intercept, so we have to graph this. Now, we're going to use the rise and run method to graph this. So let's do this now. Well, the slope is 1/2, right? The slope is 1 over 2. So you know that I'm going to rise 1, and then I'm going to run to the right 2, all right? And so my starting point now is going to be, can I make this a little bit bigger? Let me zoom a little bit bigger, guys, so we can get a graph a little bit clearer. Let's go to 150, all right? All right. So my starting point is going to be the y-intercept, right, which is 4. So that's 4 right here. Now, according to my slope, I'm going to go up 1 and to the right 2. So up 1, 1, 2. So that's my point right here. All right. Up 1, 1, 2. But guess what? I'm going away from the x-axis, all right? So I need to go in the opposite direction. So what I'm going to do now is I'm going to reverse it now. So instead of going up 1, I'm going down 1. All right. And instead of going to the right 2, I'm going to the left 2. I need to go in the opposite direction. So let's go back here now. So let's see. I'm going down 1 and to the left 2. 1, 2. Okay. So here we go. I'm going down 1 and over 2. 1, 2. And then I'm going down 1 and over 2. 1, 2. And I'm going down 1 and over 2. 1, 2. And just to make sure, I'm going to go through the x axis. Going down 1 and over 2. 1, 2. So you can see now if I draw a line, right, my x line is going to cross the x axis at -8. And so my x-intercept is going to be -8, comma 0. All right. All right, good. So that was number 5. Okay, number 6. Okay, this is a word problem, and I wish I had a little more space to do this here. Okay. Okay, so you're going trick or treat, and you're starting with 10 candies. So initially, you start. So that should tell you that's going to be your B, your Y intercept, right? Start with 10, and you're able to add candy to your bag after visiting X houses. Okay. If you can visit the maximum 5, what is the range of the function? Well, let's see. And they give you I thought they gave you the equation for this one. Yes, it didn't show up. Number 6, yeah, the equation is given, but for some reason, it didn't populate on the review. The equation, right, to model this problem is f of x is equal to 3x plus 10. It's on the hard copy of the notes, but it didn't transfer over to the slide here. Okay, so they want to know what is the range of the function. So, so my x value, my input, right, is going to be because for you to get candy, you have to go to the house first. You start off with 10, but for you to get more candy, you have to visit each house. So my houses, right, is going to be my input on my x value. Okay. And therefore, my y values is going to be the candy I get. All right. So, and that's just f of x right there, whatever that's going to be. All right. So let's find our range now. We know we start off with 10, all right? And that's when zeros. We haven't visited any houses yet. So when x is 0, 0 houses, we start off with 10. And we can prove that, right? F of 0, right? F of 0, when x is 0, is going to equal to 3 times 0 plus 10. And that's going to equal to 10, just like that. Now, after our first house, how many candies are we going to have after our first house? That's when x is 1, our first house, right? So when x is 1, what is y going to be? Let's see, f of 1, that's my first house, going to equal to, replace x with 1 now, 3 times 1 plus 10, and that's going to give me 13. All right. Let's try our second house now. That's going to be x number 2. When x is 2, that's my second house. So f of 2, right, is going to equal to 3 times 2 plus 10 is equal to 16. Now, if you notice, I'm going by 3 each time. All right, so 16. So do I really have to go through all the equations? Not really, no. Because I noticed that the amount of candy I'm getting for each ounce is going by 3. So on my third ounce, I'm going to get 19. On my fourth ounce, I'm going to get 21. I'm going to have 21. And then at my fifth ounce now, I'm going to have 24 candies. So I didn't really have to solve. I could, once I see the pattern, I can stop, evaluating the function. And so my range now is going to be, did I make a mistake here? I'm sorry. This should be 22 here, and this should be 25. Sorry about that. 25. And so my range now is going to be, remember, this is discrete function, okay? So my range now is going to be 10, 13, 16, 19, 22, and 25. So that's my range. Okay. All right. So let's do number 7 now. I'm going to erase this. Well, do I have to erase that? No, I can't extend. Well, I need to see this part right here. Okay. Very similar problem to one before, right? I'd rather you pause the video and try this on your own and see if you can get it. All right. Let's see. You go to work, out to the gym, and before arriving at the gym, you already burn 20 calories. So you know that's going to be your B right there. So my initial value, B is going to be 20. All right. And then you work at a rate of 500 calories every hour. And again, the equation for this is didn't show up. It's going to be um, f of x. All right, I give you the equation. F of x is equal to 500x plus 20. Okay, and want to know what is the range? It's not a range again. Okay, yes. What is the range after 2 hours? So every hour you're burning 500 calories. And really, do you need a? Well, you can figure this out without even using the function. All right, so we know that my input, right, is going to be the hour, and my output y is going to be how many calories you burn after every hour. So when x is 0, right, at 0 hour, before you even get to the gym, it tells you that you ought to burn 20 calories. All right. Now, after 1 hour, how many calories have you burned? Well, when x is 1, we're going to find f of 1. So I'm going to replace x with 1. Sorry. I'm going to replace x with 1. So wherever I see x in the equation, I'm going to replace it with 1. So 500 times 1 plus 20, and that's going to give me 520. So after 1 hour you've burned 520 calories. After the second hour now, how many calories have you burned? Well, let's do that. So what I'm going to do now, I want to find f of 2, so I'm going to replace x with 2, and so that's going to be 500 times 2 plus 20, and that's going to give me, well, 500 times 2 is 1,000, um, and, and plus 20 is going to give me 1,020 calories. All right, so 1,020. So my range now is just going to be 20, 500, and 1,020. So that's my range right there. Okay. All right, so that was number 7. Look at number 8. Okay, number 8 asks to determine if the tables are a function of x. So remember, we talked about this in class, right? It's a function, right? If it's a function if the x values don't repeat themselves, right? So if the x values repeat themselves, it is not a function. So let's look at the first one here. Let's look at the x values. We have -2, -1, 0, 1, and 1. here it repeats itself, and because the x values repeat itself, this is no. This is not a function. On the second one, we have 10, 9, 7, 5, 3. This is a function because the x values don't repeat themselves. Right? That's pretty easy right there. All right. This is what we did earlier on the word problems, right? Where evaluate the function. And so it gives you the function and asks you to find g of 5. So wherever you see x in the function, you're going to replace it with 5. So that's going to give me now g of 5 is going to equal to negative 8 times 5 plus 12. Oops, sorry. Plus 12. All right, so that's negative 40. I'm sorry. G of 12. Is it 10? Okay. I think this got changed. On the review, it has okay. On the review, it has the equation is negative 8. Yeah. Okay. Something's on the review that I'm giving you is different. So let's do this real quick. Number 9, let's do this. Number 9 on the review is this. This is number 9. Make sure you guys don't get confused. This is number 9. And then number 10 is going to be, okay, this is difference. Yeah. So this number 9, let's say this number 10 is going to be f of x is equal to 3x minus 2. Sorry about that. They changed the review after this was posted. So number 10 is going to be f of x is equal to 3x minus 2. 3x minus 2, and then you want to find f of 9. All right. And then number 11 is going to be f of x. No, that's not it. Number 11 is going to be f of x is equal to 2x plus 6. And you're supposed to find f of negative 4. All right. Okay. All right. All right. So let's solve this then. Pretty easy, guys. Just want to make sure the video matches the hard copy of the note, the review. Okay. So we want to find j of you're given g of x is equal to 5x plus 9. You want to find g of 10. So again, wherever I see x, I'm going to replace it with 10. So j of 10 is going to equal to 5 times 10 plus 9, and that's just equal to 50 plus 9, which is 59. All right, pretty simple right there. And then number 10, okay, you're given f of x equals 3x minus 2. You want to find f of 9. So that's going to give me f of 9 is going to equal to now 3 times 9 minus 2. 3 times 9 is 27 minus 2. That's going to be 25. Okay. And then number 11, f of x equals 2x plus 6. And you want to find f of negative 4. So replace x with negative 4. And that's going to give you 2 times negative 4 plus 6. And that's negative 8 plus 6. And the answer is going to be negative 8 plus 6. And that is negative 2. All right. So that's 9, 10, 11. All right. Here you're given a graph and you ask to find the domain. Remember in class, I told you in class, if you have a straight line with arrows on both ends, right, the domain and range are going to be the same. So in this case, right, the domain is going to be negative infinity is less than x to positive infinity. And the range is going to be the same, negative infinity less than x less than positive infinity, right? Again, whenever you have a line, straight line with 2 arrows at the end, that's going to be the domain. And this is a continuous or discrete. Remember, it's a line, so it's going to be continuous. All right, it's a straight line, I should say. If I use a vertical line test, it only crosses the line at one point. All right, so that's number 14. Number 15 here, you actually find a domain. Remember, domain is we want to find an x value. So I'm just going to draw a line from start with the leftmost point, draw a line to the x-axis, and that's going to be -2 right there. Next one is going to be -1. This is going to be 0. This is going to be 1, 2, and 3. All right. So my domain is going to be -2 all the way up to 3. And the range is going to draw the line now to the y-axis. The range our y values. Now this time you're going to start with the lowest point. This one is my lowest point. I go to the y-axis. All right, that is 1, 2, 3, 4, 5. That's -5. The next one is -3. Next one is it's already on the y-axis, which is -1. Go up, that is 1. This one is 3, and this one is 5. All right, and so my range is going to be that. Is this a continuous? Yes, because if I draw a line, I don't have 2 points that are directly under each other. All right, so I'm sorry, this is a discrete. Think what a function. Yeah, it's points in the graph, points, so that's a discrete graph. All right, so that's number 17. And then, where we going? 18. All right, here, very similar to the ones we did before on, what was it, number 6 and number 7. Very similar. Okay, so I'll go ahead and pause the video. You will need the equation. The equation is uh, f of x is equal to 20x plus 4. And this is a star question, all right? Very similar, all right? The gym has a set of weights and a 4-pound barbell and pairs of plates are added to the barbell. The total weight of the barbell and plates in pounds can be represented by the equation given right there. Now, if gym has a maximum of 6 plates, 6 pairs of plates, what's the range of the function? So think of it now. You have the barbell. You have a barbell, right? I'm just going to draw. I think it looks like. Oops. I'm in the gym a while, but let's see. You have a barbell. It kind of curves and something like that. So that's a barbell, and it weighs 4 pounds. So before you put any weights on it, all right, the barbell weighs 4 pounds. So when x is 0, right, um, we're gonna have 4. So let's draw my little table right here. So we know our input is gonna be the barbells, right? So barbells are gonna be my input, and the output is gonna be how much the barbell weighs after putting the weights on it. Okay, I hope I didn't confuse myself there. Second, f of x. All right. So let's find out now. So we know when there's no weights on it, right? When x is 0, when there's no weights on the barbell, right? The barbell weighs 4 pounds. And we can prove that from the equation right here, all right? F of 0, right? F of 0, right? When there's no when there are no weights on it, is going to be f of 0, which is going to be 20 times 0 plus 4, which is just 4. Now, when we put one pair of bars of plates on it, right, one pair, so f of 1 now is going to equal to, and each pair, right, weighs 20 pounds. I think it tells you somewhere in that. But the equation does tell you that. All right. So when we put one pair, I'm going to get 20 times 1 plus 4. All right, which can give me 24. All right, let's try. When we put our second pair now, our second pair of plates on it. So f of 2 now. All right, I put my second pair of plates on it now. It's going to be 20 times 2 plus 4. That's 40. That's 40 plus 4, which is 44. If you notice now, I'm going to buy 20, all right? So do I have to do the math on the right side? Not really. We go up to 6. So it's 3, 4, 5, 6. So I'll go by 20 again. So that's going to be, no, this should be 44, right? Yeah, this should be 44. Go by 20 more pounds. So that's going to be 64. Another 20, that's going to be 84. This is 4. This is 5. For 5, not 20, that's going to be 104. And for 6, it's going to be 124. See that? I could do the math and still get the same answer on the right side for the range. And so my range now, ask for the range, right? Yeah, what is the range? So the range is just going to be, I'm just going to list, this is all my range right here. It's all my range. So it'll be 4, 24, 44, 64, 84, 104, and 124. That is my range right there. Okay. All right, so let's see what's the next one. 19. All right, which inequality best represents the domain? All right, so remember domain and x values. So I'm going to find where the graph starts on the left side. So the graph starts right here. If I go up, that is negative 3. This is a closed circle, so I'm going to have less than or equal to. The graph ends right here, which is 2. This is an open circle, so I'm going to have less than. So which one is that? That's going to be B. Next one is number 20. All right, number 20 now. Look at the domain. Where does the graph start at? All right, it's negative 4. Graph starts right here. That's negative 4 right there. All right. But notice now all the x values are increasing, right? All increasing. All right. And the graph has an arrow, so we know it's going to go to positive infinity. The graph keeps on going, my x value keeps on going up. So all my x values, right, for this domain are greater than negative 4. Greater than the negative 4. It's open circles and a closed circle. So it's going to be x. All my x values are greater than negative 4. So the answer is A. Now, if this was a closed circle now, then I would have x greater than or equal to negative 4. All right? Okay. Okay. Let's see. That was number 20. I think that's it. There are a couple more. Wow. 2020. There are a couple more that didn't get added to the review sheet. But those we can go over in class, okay? Um, yeah, number 21 is a good one. It didn't. I'll go over that one in class. Or what I could do, I'll make a separate video for number 21. It's not on the review slide. All right, guys. So that's the review right there. I'll hold you one more, and so I'll add that in a separate video so you can look at it. All right.